Hello, physical scientists. Ms. Getz here. Today we're going to do a self-paced set of notes so that you can pause this video if you need to, and you can go faster through it if you would like. Feel free to change the speed of this video as you are watching, and you will need your notebook with you to set this up as notes you can look back at. So our guiding question for today is, how can I calculate velocity? We learned that our car in our lab travels at a constant velocity. That means that it keeps going the same amount of distance every second in time. And so today we're going to make sure that we feel comfortable with calculating velocity in a couple of different ways. Before that, though, I wanted to review how we measure different things, because I think that's something that you've learned a little bit about, but can use always a good review for. So when we're measuring distance, that's how far something goes. We'll use centimeters, meters, and kilometers in science class. You might have noticed that in everyday life, often we use inches or feet or miles, lots of different units that we use in the imperial system. These are a little bit annoying to do calculations with, and so we're going to stick with centimeters, meters, and kilometers in science. And for time, you know these pretty well. That's how long something takes. We've got seconds, minutes, and hours. We've also got days and years and decades and centuries. And there's lots of different ways that we can measure time. And again, in science, mostly we'll have meters and kilometers, sometimes miles, sometimes centimeters, and seconds and hours when we're thinking about measuring velocities. So velocity is also known as speed, and it's how fast an object is moving. When you take a physics class later on, velocity is actually something that has both speed and direction. It's both how fast and where it's going, and speed is just how fast. But in physical science, we're not going to stress about the difference. We're going to use the words as pretty much the same. So speed and velocity for us, same thing, how fast it's going. And it's the rate at which the object is moving. So a rate means it's an amount per time. So it's how far it goes per amount of time it takes to go there. And so we actually have three different equations. They're the same equation, just rearranged algebraically. We're not going to worry about the algebra here in science class. And I would actually take a moment to jot some of this down on page 17. I would definitely write down speed or velocity is how fast an object is moving. And I would also write down that it's the distance divided by time. So we have our equation for speed right here, distance divided by time, and our equation for time when we have the distance and the speed, our equation for distance when we have the speed and the time. So I would jot these down. You can pause the video if you need to and write them on page 17. So when we're solving problems in science class, they're usually going to be word problems. And I know that you really love word problems from math class, right? What strategies we're going to use in science class will make our word problems a little bit easier. We're going to use some really specific strategies. And the first one is identifying what you know in a problem. So here in this problem, it says Abdus-Salam walks to school. He lives 3 kilometers from school, and it took him 10 minutes to get here. What was his average speed? So in this problem, I'm actually going to go ahead and think, well, one thing I know, it's giving me this number 3 kilometers. That's the distance. And it's also giving me this other number, 10 minutes. It's the time. So when we're working with problems, we're going to use strategies to help us break them down and make them a little bit easier. The first one is figuring out, what does the problem say? So that's what I just did here. It's giving me a distance and it's giving me a time. Then we'll think about, what are we calculating? Am I calculating speed, distance, or time? What formula are we using? And then we're going to actually show our work. And this step is really important because it allows your teacher to notice, or another classmate, or you in the future, to notice what you're doing. And if you make like a small mistake while you're doing the calculation, and I can see your small mistake, I can still give you credit because I can tell you know how to do it. You just maybe switched the two numbers around or something. Then we calculate our answer and write our units on the answer. And we're going to be using this little graphic organizer on our problem sets to help you organize your work and keep track of what you are doing. So let's look at a problem together right now. I've got this problem about a monarch butterfly, and it can fly about 322 kilometers in 24 hours. That's really fast. What is the butterfly's speed? So what I'm going to do is first think, what does this problem say? It has this number, 322 kilometers. That's the distance. So I'm going to write distance equals, or D equals 322 kilometers. 24 hours, that's the time. And then it says, what is the butterfly's speed? Well, that means that speed is something I want to find out. And so I put a question mark there to say, I don't know what it is, but I want to find it. Then our next step is thinking, what are we calculating? Well, speed has a question mark, so speed is the thing we want to find. Then we're going to write our formula, and we're going to write our formula out either in words, so speed is equal to distance divided by time, or in letters, S equals D divided by T. I tend to do this because I'm a little bit lazy. This one works okay too. But you do want to make sure that you write down which formula you're using. And then I'm going to go ahead and show my work. 322 km divided by 24 hours. And I'll plug that into my calculator and get this number. You can round to the tenths place, so 1 decimal point. And then we write our final answer. We've shown our work. We're going to write our answer, and we're going to add the units. And I can see here that there's kilometers and hours. And the units for a speed always have some distance divided by some time, like miles per hour. And in this case, it's kilometers per hour. So this example problem, you could have jotted down in your notebook, but you don't need to, because I actually have an example problem for you that you can pick up from the front of the room. There's a nice handout there for you that summarizes speed, time, and distance, the units that we use for them. So this units for speed, the units for time, the units for distance, and our 3 different formulas, all on this nice handy sheet, as well as an example problem that I'll go over in a moment. But take a moment right now, pause the video, and go grab this, tape it into your notebook as a flap, so it's a book page that you can see underneath. So then this last example we're going to go over is similar to the problems you're going to work on solving today. It says, calculate the speed for a car that went a distance of 125 kilometers in 2 hours' time. So notice that I have actually highlighted the different parts, the different words in this problem that helped me figure out what was going on. Speed, well, it says calculate it. That means it's a question mark. I want to find it. Distance of 125 kilometers, well, that means I know the distance and I know the time, 2 hours. So then I went ahead and thought, well, which formula? I want to find the speed, so that's the formula I'll use. You can write it like this. This is how you might type it into a calculator, 125 divided by 2. I usually write it like this. Either way is fine. I typed it into my calculator, and I got my answer, which I wrote out with the correct units. So I have the number and the units. This should say km per hour, not just k. My bad. Sorry, team. So hopefully this was helpful for you, and you can go ahead and take a picture of this page, page 17 in your notebook, upload it to Schoology. And if you want a little bit of a preview of the first problem on your next assignment, I'm going to set it up right now. But you don't need to check this out. You might find it helpful, but I think, it's up to you. So our next problem, and this is actually in your next assignment on Schoology, is a soccer ball is kicked a distance of 20 meters. What is its speed if it takes 0.5 seconds to go that distance? So again, I did some highlighting here that will help me solve my problem. It's going to help me start out by saying, what does the problem say? Well, it gives me this piece of information, 20 meters. That's my distance. Write it down here. What is the speed? So that means that speed is what we are looking for. And the time is 0.5 seconds. So I've written down all of the stuff I know from the problem, what it says. Then, what are we calculating? Speed, distance, or time? Well, speed is our unknown, and it says, what is its speed? So that means speed is what we're calculating. And we want to determine which formula to use. Well, I want this formula that says speed equals. So that's this top one right here. So I'm going to let you complete showing your work, how you're going to calculate the speed, and write down your answers. They'll have units meters per second. And you want to take a little moment and a lot of moments and give these problems a try. So folks, again, if you haven't, upload page 17, please, to Schoology and move on to the next assignment. Thanks, guys.